Good afternoon and good evening. Welcome to our Bright Talk Summit Data Architectures talk with data platform capabilities for modern data management and architectures. Today, joining us as a regular is Jeremy Bentley from the strategy side of Mark Logic, and Matthew Gonzalez will be joining us from the product side to talk in more detail during a question and answer session between us at the end of Jeremy's talk. Hope you can join us for these and future events. We've got a number coming up, including a new series that our Mark Logic community series for our engineers, developers, and architects to really get to some of the more technical side of the technology, share stories and make learnings from there as well. So that's coming out hopefully at the end of May. Details should be out shortly. But without further ado, I will pass over now to Jeremy. So Jeremy, it is over to you.
Well, thank you very much. Thank you for joining if you're watching us live, and thank you for watching if you're doing it through catch up. It's greatly appreciated you give us your time. Hopefully the concept of modern data management architectures is a keen one for you. So we'll start with a little story. 3 relational databases walk into a NoSQL bar. They left after 5 minutes. They couldn't find a table. But really, today we want to talk about modern data architectures and how they're changing the way we think about data management. I mean, clearly it's axiomatic to say that data is the lifeblood of business. Yet since the start of electronic data processing, which is an old word chosen specifically, we've been stuck with the restrictive Uber architecture of an application-first, data-second world. It's fully understandable. The choices made until recently are, to do with prior restrictions on processing, memory, network capabilities. But the world has evolved to cloud, infrastructure on demand, and the economic imperative of being a data-driven enterprise. So actually, architectures are evolving too, to deal with the new world, to do with data-driven decision-making by all commercial businesses, all government enterprises, everybody. So this session is about, it's high time to look again to see how we may cancel the more restrictive effects of the old way of working with data. I mean, all the while we have to acknowledge the skills, the investment and the mission critical nature of our existing data systems. But how does one augment what's already there? How do we avoid rip and replace of what we've got? Because we've got this very large investment in how we've gone, of investment we've made to date. How do we deliver data agility such that our data systems can respond nimbly and quickly to rapidly changing business demands? That's the subject today. So I mentioned application first, data second, a restrictive Uber architecture. Well, what is the first restriction? Well, it's application data silos, no surprise. And the need to take an integration, and with those silos, there's a need to take an integration-centric approach to feed our business's appetite for data that cuts across the data silos and organizational boundaries. And the issue is that the more silos, the more integrations. The more integrations, the more complexity. And the function for this is exponential, not linear. If you're interested in the maths, just go and search for organizational theory of communication complexity, and you'll see that it is exponential. So it's no wonder that our data systems are slow to respond to change when either further integration or changes to existing integrations are required. The second restriction is the proliferation of different data and application species to suit the various application tasks. So, for example, we keep records in a document management system as unstructured data, and details of the transaction that this record pertains to in its operational data store, normally as structured SQL. But fast forward from how we have been working to now, what we have in every organization is hundreds, if not thousands, of applications with specific information needed to undertake their specific tasks managed by their own task-specific database. This means that not only is data held hostage within its application boundary, but so too is the knowledge about how to process this data. No wonder our data suffers from quality, governance, security, unity, and context issues as we seek to answer complex business problems, process complex transactions using complex data pulled from across the complex data ecosystem. So, over the past few years, there's been a significant shift in the way that organizations approach data. Many businesses are already embracing newer patterns than just the square data warehousing mode. You'll find more patterns and technology options than ever before, from data warehouses, data lakes, newer data lakehouses, and data hubs, or what is perceived as even more innovative, the data meshes and the data fabrics. And I haven't yet introduced how and when to incorporate active metadata, semantic knowledge graphs, and how we feed and get value out of our machine learning and artificial intelligence working over our data. So if we look at the slide, all these architectures that I've mentioned, which sit on top of the MarkLogic data platform, they're all configurations of the same platform. All these architectures are possible configurations of the MarkLogic data platform, and uniquely to us, you should view them as a set of capabilities delivered from a single unified platform that enables a seamless evolution from one to another. It can be a little trepidatious to think, well, how do I do a data fabric? But actually, it's an evolution from one to another. And as you become more conversant with the skills and capabilities needed to implement each, for example, you might choose to start by implementing a Lakehouse. And as your metadata management capabilities develop, so you can evolve into a mesh and then into a data fabric. And that data fabric is supported by knowledge graphs that act as a control layer for quality, context, and unity. So innovation's proliferated as demand grows into our better ways to manage the massive amounts of data in its various forms produced by enterprises every day. So how can you make sense of this changing landscape and choose the best fit architectures to meet your organization's needs? Today's talk is a start, as I briefly chart the recent evolution of data architecture patterns, and I'll describe each of the primary architectures in use today, including their benefits, limitations. If you could, please just put questions in the chat, as Mattia will be answering as many as he can in the time on this session. But firstly, I think what's really important is there's no best data architecture, one that, if you like, rules over others. Only the right one to address your organization's specific use cases and business challenges is the right one for you for that particular project. It could be a tactical project, it could be a strategic project. But of these new architectures that we're going to be discussing shortly, there's no right or wrong answer, but there are a lot of big differences, and actually let your decisions be guided by what works for you, not by what's hot or what's hyped. So I want to introduce the data supply chain. I talked at the beginning about application, the Uber architectural restrictions of application first and data second. The application giving rise to silos, and data, if you like, being a second-class citizen. And actually, all these modern architectures are about putting data first. We've been through the reasons why there were, good, sound decisions taken to limit resources of memory, bandwidth, and resources. But actually, that's changed. MIPS are pretty free. certainly a lot freer than they were 30 years ago. Infrastructure is on demand, and networking is extraordinarily faster than it used to be, and businesses are working in real time. So all the modern architectures, looking at this slide, that we're going to be discussing, have some or all of the elements that I'm showing on this slide. The first is the ability to connect to any data in any format, in any volume, to any language for any application of any architecture, of any age, of any workflow for any process. So this idea of connecting and or ingesting, and the two we can discuss a little bit about, when one's more appropriate than other, perhaps that's a good question. Once we've connected to all and any, how do we create and interpret our data and inject, if you like, governance, context, unity, security, and quality in that creation and interpretation? And then how do we consume? Because actually applications consume and then create more data. So it's a repeat process. And we call this the data supply chain. And we configure the MarkLogic data platform to achieve your desired business outcome. And whether that's whether that's a lakehouse, a mesh, a hub, a fabric, a knowledge graph driving a fabric, that's down to the actual specifics of your requirements. But the MarkLogic data platform can do it all. And it's the specifics of each architecture demands different levels of orchestration, different levels of interpretation of the data, such that the actions of this connect, create, consume are called upon. And it's called upon many times in different sequences to advance the data through its supply chain. It is a data-first approach. And by adding the data platform to your existing data ecosystem, we address the issues of the Uber architecture that we talked about earlier, taking the old application-centric and making it data-first. We're delivering data agility, solving the most complex data problems simply. I plan now to go through the specifics of the more modern architectures one by one. We start with data lakehouses. We then move on to the data mesh, look at the data hub, look at the data fabric, look at knowledge semantic and knowledge graphs. And there is an evolutionary, if you like, sophistication. And that order is determined starting with the simplest and moving up the sophistication scale, if you like, of the type of metadata skills needed to implement each. As you'll see as I go through it, metadata, which is the meaning, data about data, information about information. The aboutness is actually the key word in that in that sentence. We're talking about data and its meaning. And none of these architectures operate without metadata. And metadata comes in many shapes and forms, but some of it is simple, some of it is, in the middle of the complexity scale, and some of it is, active and orchestrating, and it depends on your skill set in-house and with the partners that you choose to implement these things on, which is where you might want to start. But every one of these architectures has a specific use. It's good at certain things, not so good at others, and I'll try very quickly to go through what those might be. So let's start talking about data lakehouses. I can't resist it. I did see a great movie about databases today. I can't wait for the sequel. So a data lakehouse is actually a hybrid approach that combines the best features of a data warehouse and a data lake. It provides a centralized repository for all data. That data is structured, semi-structured, unstructured, and it allows for ad hoc queries and analysis. So we're already starting to see that the main advantage of a lakehouse is that it can support both batch and real-time processing, which makes it ideal for organizations that need to handle, large volumes of data that's rapidly changing, or just large volumes, but where you need, potentially real-time access. This concept of batch has gone. However, it actually can be quite complex, and it does require careful data quality assurance to ensure that the data is accurate and up to date, and, if you like to use old words, joinable. And that theme will come through with a lot of the different architectures that we're looking forward to seeing in a minute. Before I move on to data meshes, I ask you a question. Why did the database administrator slice a tree stump in half? Clearly, they needed a binary log. So, data meshes, right? What is this? It's a distributed architecture that breaks down data silos and allows teams to manage their own data domains. So this approach is particularly useful for organizations that have multiple business units with their own unique data requirements and likely their own data management control structures. So it allows each team to be responsible for the data within their domain, and the architecture is providing the tools and the infrastructure to enable them to do so, but actually ultimately share the information. The main advantage of a data mesh is that it can help to improve data quality, and it reduces the time and cost associated with data integration. When I talk about its potential things to watch out for, I mean, it's quite complex because there are many independent actors involved, humans who've got their own domains, who are managing their own data. And actually, when you think about the many different actors, then what this starts to require is careful metadata management and curation to ensure that the data is unified, accurate, and up to date. So if we move on, look at the third architecture, the data hub. A data hub is a centralized platform built essentially for data exchange. It's allowing for integration management and sharing of data across an organization. But it acts as a hub or a central repository for all data within an organization, regardless of its format of source, regardless of its species. I think the key thing here is it's usually in the cloud. It doesn't have to be, but there are a lot of economies of scale if your data hub is in the cloud, and certainly MarkLogic's data hub is predominantly in the cloud or on a private cloud. I think the key thing about data hubs are that they're designed to handle large volumes of structured and unstructured data, various different sources, internal systems, cloud-based applications, and external partners. So when I talked before about the need for data agility, the need to be able to cross not only just data silos, but also organizational boundaries, a data hub in the cloud is often the right answer for that kind of complex data issue. Data is collected, processed, and organized within the hub. It allows for easy access and sharing data across the different departments or functions within an organization, and it allows for sharing of information with partners because the security protocols within the hub are transformational compared to the old way of working. Another point about data hubs is that the data's persistence, i.e. how long you keep it, is configurable. It might be from being a short-term cache all the way to being a source of record. You keep it as long as you need it for the task in hand. It's configurable. You can change your mind later, but it serves as a central point for managing data integration, data transformation, and data governance. Typically, a data hub is designed to support data integration. It's actually, when we talked about earlier, I mentioned this integration complexity being an exponential function. its job is to reduce the integration complexity that I talked about earlier by giving one place to go, compared to the point-to-point integrations the world has typically undertaken in the past. So it can be used to support data discovery, data lineage, and other data management activities as well. And the basic benefits are data quality, increased efficiency, enhanced analytics, improved collaboration. So moving on to data fabrics. This is another statement that I couldn't resist, but do you know how data scientists quantify rabies outbreaks? In megabytes. We look at what a data fabric is. It's a virtualized automated control layer over the existing data ecosystem. It's providing all of those capabilities that we looked at on my second slide. It's providing the governance, the security, the context, the unity, the quality over time, over all and any data. It is essentially the control layer over your existing ecosystem. It allows organizations to quickly and easily access data from the different sources. It's providing a unified view of the data. Fabrics help to reduce data duplication and improve data consistency. And it is the fabric implementation that is controlling, orchestrating the data's movement through its supply chain. But it does require, data interpretation, data orchestration, active metadata management. And these are all capabilities of the MarkLogic data platform. But the skill set is potentially something you grow into as your enterprise skills are honed by maybe first implementing a mesh, a hub, or a lakehouse. So what I wanted to get across is the idea of MarkLogic is the strategic answer to what may actually be, an evolution in these modern data architectures over time as your enterprise and your skills are honed, and as you get more and more comfortable with taking a data first approach. My last architecture is the knowledge graph. It's slightly to one side from the hub, the fabric, the mesh, because it can implement against all of them. But before we start, I should tell you that I collected a lot of data trying to disprove confirmation bias, and the results were exactly what I expected. A knowledge graph is a graph-based data model that represents information as nodes. And the graph term are nodes and edges. In real-world language, nodes are objects, entities, and concepts. And the whole world of business works on objects, entities, and concepts. And the edges are the relationships between them. So when we say profit is up due to lower fixed costs, we have just communicated a very fundamental business concept, and we've linked the concept of profit to costs. And the knowledge graph is capable of representing that knowledge in a very accurate, very profound way. I mean, a very simple example to visualize maybe was a healthcare example, whereby, diseases are related in different ways to symptoms and treatments. Symptoms are related to tests. Treatments are related to drugs, and drugs are related to both dosage and known interactions. It's a tiny little universe of a graph. And what hopefully that example and the idea of it is that by imposing a knowledge graph over your existing data ecosystem, whatever it is, we can calibrate, interpret, and orchestrate the data using your defined best practices, which are captured in the knowledge graph. I mean, it's particularly useful for organizations that have complex data relationships and have a need to identify patterns and insights across multiple data sources. The main advantage of knowledge graphs is that they can help to uncover hidden insights and the relationships within the data. And that's particularly useful for organizations that need to make data-driven decisions and be certain of the relationships and concepts being used in this decision making. It's not a coincidence that regulated industries who have to be very careful of imposing data quality on their data and making sure they're absolutely certain about whatever compliance tasks they have to do with the early adopters of knowledge graphs. And I would point out again that knowledge graphs are usable standalone or as this control layer over the previous architectures that I mentioned. So in conclusion, for this part of the session, before we move on to questions, modern data architectures are changing the way that organizations approach data management, and they're providing new ways to store, access, and analyze data. And whilst each architecture has its strengths and weaknesses, they all require careful management and the use of metadata to ensure that the data is described, it's accurate, and it's up to date. And so you're basically addressing the data, i.e. how things are, with the meaning of that data, what they mean. Right? And as we continue to see the advances in technology and data analytics, and this is not the end of the journey for sure, we see that the organizations that have already adopted the architectures discussed and who continue to evolve as our data world evolves are the strategically well-positioned ones. But before I leave and pass over, if you think that your microwave is collecting data and the TV is spying on you, it's bad enough. Well, the vacuum cleaners have been gathering dirt on us for years. Thank you very much.
Hi there, Jeremy. Thank you for that. Thank you for leaving us on a high note there. We're joined by Matthew Gonzalez, VP of Product Management here at Mark Logic, with us today, and we've got into some time, so we'll make sure that we make the most of him. I've got some questions before we go on to the Q&A from our customers. I just wanted to sort of make sure that we get the most out of Matthew on the call. So, without further ado, Matthew, how are organizations overcoming issues to start their data fabric or data mesh journey?
Very good question, actually. And if I try to summarize what I'm seeing on projects, I think there are two really big challenges actually that organizations need to address head on actually when they're embarking on that journey, and both of them are organizational challenges. I mean, the first one is actually technical architecture. Most organizations simply begin by attempting to choose between fabric and mesh, and that's a false debate. I mean, and it should be avoided. I mean, you don't have to choose. They work together. They're actually stepping stone from one another. I mean, both the mesh and the fabric pattern you heard Jeremy are building upon each other that take the same composable metadata approach over your existing data. The second very often discussed question internally is, are you ready to embrace data agility? Are you ready to accept that the control of the data belongs to business and the control of the platform belongs to IT? I mean, if you try to put to keep the control of the data within the IT without involving the subject matter expert or the business analysts enough, you're not going to get the benefit. You're still going to be stuck in a fairly long development lifecycle, etc. Even if you've got active data ops or DevOps and CI/CD practices on the implementation side, your data lifecycle is extremely fast. I mean, your ability to add concepts, constructs in a graph, it means you can recycle your data, you can test new approaches in a matter of hours, in a matter of days. And you really need the IT, the data scientist, and the business analyst to work hand in hand and accept each other's responsibility, which for some organizations actually a really big change.
Yeah.
I think, maybe there's also actually another thing that Jeremy touched on as well, which is rip and replace versus build and assemble. Data mesh, data fabric, knowledge graph, they're add-on technologies. They're composable. You add them, you layer them on your existing data platforms. It's not rip and replace. I mean, you can really build upon it. It's not. It is disruptive in the value that it brings, but it's not necessarily disruptive to the infrastructure.
Yeah, especially if you've got the right platform underneath those technologies.
Yeah.
So in terms of then, is it connecting the data to to the sources, or is it collecting? Are you is there a difference?
There is a very big distinction between the two, but the two are actually valid implementation pattern. And whether you collect the data, keep it in the data hub or in the data fabric, and overlay the metadata to have a navigable ensemble in one place, or whether you simply keep the data where it is and connect it with metadata inside a metadata hub, really depends upon your use case, upon the nature of the data sources that you're integrating as well. I mean, there are a few cases where you've got very clear-cut decisions you can make. I mean, let's say you're, for example, exposing data that is in part or in whole kept in a mainframe. I mean, scaling out your mainframe will be extremely expensive. And if you need to support very high load at peak time of the day on a web service, for example, you're not going to scale the mainframe to that. So in that context, scaling out your data hub is very inexpensive in comparison. So yes, in that case, you're going to cache the data. Likewise, I mean, if your data is changing really, really fast, you may want to keep a stable copy in the data hub. If you've got to do a lot of pre-processing or a lot of transformation to your data before it's actually exploitable, then metadata is one thing, but data may also need to be transformed before it can be presented. So again, another case where keeping a stable version of the data really makes sense. But in other cases, collect versus connect really depends upon how you want to approach it, whether you want to delegate control, whether you've got sensitivity in some of that data and it needs to be retained at source. So very project specific in those cases.
And is the number of authoritative data sources, in ecosystems impacting or going to impact the choice between a mesh and a data fabric?
It is. In the presentation that Jeremy did, one of the key difference between a mesh and a fabric was the amount of metadata included or overlaid in the store. Very specifically, the amount of active metadata actually that is being generated and being considered. And some of that metadata is actually mapping of the data sources. So if you've got a single authoritative data source and you key everything around that, a mesh pattern is absolutely fine because everything will simply go back to that model. It's almost a canonical model in its own right, and fine, everything will hang together and you can exploit it there. If you need to start mapping those multiple authorities, mapping and aligning your entity types, mapping your domain, doing crosswalk, well, all of the extra metadata needs to reside essentially in your fabric and in the knowledge graph actually of the fabric as well. So in that case, I mean, if you've got multiple authoritative data sources and you need to map them, then yes, you're pushed towards the fabric, definitely.
Yeah. Okay. And I guess this is, a question that's going to be for a lot of organizations, big or small, which is, do I need a data science team or an information science team before I embark on using a data fabric, going on this data fabric journey?
Very good question indeed, because you've heard Jeremy, you've heard me mention several times now that the fabric, builds on top of the mesh by adding more metadata, by adding more active metadata. So yes, the maturity of your metadata experience, of your metadata team, of your metadata strategy is an essential part of progressing from a data mesh to a data fabric. So yes, you need a trained information scientist, data scientist, or a business analyst, or subject matter expert that have interest in those domains. But it's not a all or nothing approach. You can have a perfectly working, well-formed mesh and decide that for this specific area of documents or records or data sources, you're going to enrich a little bit more. And you can go step by step, and you can build your metadata maturity over time, gradually with your team, additional tools, additional practices, additional governance, and you can really build upon that and gradually get to a data fabric pattern, step by step. So it's a gradual journey.
Yeah, and I guess that comes down to that earlier point of, involving the quote unquote data experts on both sides of the business. So having that, those business subject matter experts and then the technical experts at the same time.
Yeah, and focusing on high value use cases. I mean, you don't need to create additional metadata for everything. When you create additional metadata for the use cases you need to serve. And if you are building your data strategy correctly, I mean, you can have very quick turnaround when you need additional metadata points, when you need additional data points, additional transforms. And the value you'll get from those data points can be leveraged almost immediately. And that's the entire point of a data fabric and being agile with your data. Very quick life cycle between your enrichment activities and your data consumption. A very quick time to value, essentially.
And so how does a data fabric design help or potentially help optimize the data management costs to organizations?
So fairly loaded question and quite a lot of angles to answer that one. But I suppose the first and immediate one is a data mesh, data fabric, a knowledge graph. I mean, all of those things are composable and they're add-on to your to data strategy. So it's not a rip and replace. So the initial investment might not be as big as the traditional. Let's throw everything we have and rebuild from scratch. So that's one thing. There is flexibility in tools and design choices because it is modular and composable. And especially if you go for a connect data implementation approach, as we talked about a minute ago, you don't need to duplicate your data. So your new system will be essentially a map of your existing data. And it's fairly lightweight. And you can get really high value very quickly from that. I think there was a quote from a couple of years ago, 3 years ago, I think, by one of the analysts, which was metadata is a fish finder for data. Great. I mean, your metadata mesh, your data mesh, and your data fabric might be the net to grab it, and your knowledge graph is the nautical charts over it, right? So you can see the added value of those things and how they build on each other. I think an adjunct cost saving here, or certainly value time to value element, is a maturity of CI/CD practices and data ops practices, because very often nowadays the data is no longer dictated by the data sources that we have, nor by the teams we have in IT building data mesh, data fabric, data warehouses, etc. But rather they're defined by end users who need to build applications and decide what information they want to subscribe to. So the ability to very quickly assemble the data sets that those application builders need is where a lot of the cost saving comes into play. I mean, you don't need to start doing ETL, doing data ingestion, doing federated queries across multiple systems, etc. The idea is to have a very quick, very repeatable system where you can get additional data sources if you need to, but with the existing data source that you have already in the data fabric, compose a new data product based on the entities that are of interest and the attributes for those entities.
Yeah.
I think, if I may just add a little bit, I think when we're talking about connect, and I'll use a golf analogy, you play the data where it lies. In golf, you play the ball where it lies. You don't have to lift the ball up and move it into somewhere else. And it's a hugely cost-efficient way, because every time you lift data and shift it, typically you go through a lengthy transformation process. Something gets degraded because transformation is always the transformation to the lowest common denominator and everything. And actually, by looking at some of these more modern fabrics, you're firstly not lifting and shifting data, you're connecting to what you've already got, and you're enriching and interpreting that data in these new modern architectures. And the interpretation is not a transformation; it's a knowledgeable, precise interpretation of the data and what it means, so that we can do harmonization in the middle, we can do extraction of data in the middle, we can do enrichment of data in the middle, but it's not a change, and it's not moving the data, and it's a massive difference in the time it takes to implement a new analytical system or whatever it is the task you're trying to implement, because you're not having to shift your data and change it in ways that ETL requires you to do.
Yeah.
And building upon that, actually, if you think about the capabilities of semantic models and the ability to version semantic models, what it also means is, without changing your data, changing your metadata even, simply by at query time accessing a different version of a knowledge model, a different version of a semantic graph, at the same time as your data and querying both, you can actually do A/B testing, try different assumptions, target different audiences, without replicating any data.
Yeah.
Same data hub, same metadata hub, just different interpretation ontologies on top of it.
Yeah, so rapidly prototyping and doing stuff that just on the existing data without having to then push it.
Yeah, I'm basically seeing your data through
but
a
also in
lens.
production. Also in production, I mean, think about, I don't know, a pharmaceutical use case where you might have someone in research with very specific data needs, and someone in production with very different data needs, or someone in regulatory reporting, again, completely different ontological representation of the risks, of the molecules, of the target audiences, different vocabularies, different relationships that can be explored on the same data.
Yeah. And then we've got some questions already coming in through the audience, and I guess I'll go to Jeremy for this one, and maybe Matthew, you can come in for the more technical part of it. But what's the differentiating feature of a cloud-based data hub? Why being in the cloud makes a difference for that?
I suppose I should be diplomatic and just ask the audience how many people work in internal IT. But we can skin up a hub in the cloud as our service, in a matter of minutes, and hubs implemented on internal infrastructure. Sometimes it takes 3 or 4 months for the server to be ordered. Once that's done, if it's in the cloud on clearly as a managed service, we're now, operating that on behalf of our customers according to an SLA, which in most of our cases, the cost and the SLA is better than most, operations are internally. Then there's the scale of just being able to infrastructure on demand means that we can burst and accommodate, within known capacities, we can scale up and scale down, So there's a huge agility that comes from being in the cloud that you just simply don't get for all sorts of very good, valid, commercial, organizational reasons when it's not in the cloud. And when I talk about the cloud, I ultimately get to as a service, run by, with a whole team of people who are running it on behalf of our clients. But the cloud is for sure where most people are implementing ops.
I mean, I mentioned earlier on that one of the very big advantage of such an approach, such a dynamic approach, is to put the control of the data and subscription to data in the hands of the application builders, in the hands of the data scientists consuming that data. If your ability to add additional data sources, do additional transforms, overlay metadata is so easy, so is your ease to actually multiply the size of the data corpuses that you have. And if you need to do that, we need to also be very agile in the way you can add disks, add memory, because it's a traditional IT system behind the scenes. So yes, it needs disk, it needs CPU, it needs RAM, it needs all of those things, and it needs it in a very agile way. I mean, you may need to provision a few terabytes of data, additional data, overnight. Those sort of things which on-prem tend to be very hard. Whether it's a private cloud or whether it is SaaS, the cloud deployment offers clearly a lot more dynamic environment for those type of provisioning. And also we're seeing more and more clients do multi-cloud because they've got this AWS service or they've got that Azure service, and you can do hybrid cloud solutions as well. You keep the data, keep the system close to where the data is.
And that's a really good point, Matt, because when we're talking, particularly we're talking to the much larger global companies, you may find that, I'm a large bank and I'm working in Japan, so I'm working with one cloud vendor. I've got the same application on a different cloud vendor in Europe, and I've got a third cloud vendor in the US. And, it's a global world, so it's all got to come together, and you've got to be able to hub, and you've got to be able to move. So this whole multi-cloud system, and actually, interestingly, for certain regulated industries, becoming mandatory to have multiple cloud vendors, because otherwise you're at the risk of one going down and organizational risk. So it is actually adding complexity to the cloud concept, but cloud is still infinitely more agile and more flexible and more capable of meeting demand when it's required. Which is why people choose it.
We've got another question that's come in, which is, what about key security, secure and compliance methods, control tools, the recommended to manage SDevOps constructions?
So it's a fairly wide question, so I'll try and answer different aspects and different elements to that. I mean, first of all, there's a data security aspect to it, and MarkLogic has always been very, very strong when it comes to data security. Role-based access control, query-based access control, all sorts of policy and role-based systems in MarkLogic to make sure that the data is only visible to those who can see that data. And conversely as well, redaction approaches. So certain fields, certain attributes of the data can be masked, anonymized, as required based on who you are, where you are, and those sort of things. So, because yes, I mean, if you make data easily accessible, you also need to make sure that you respect the original intent for the audience, for the purpose, etc. And it's even actually more important to do so, because often when the data was locked away in a data silo, maybe the entire silo was only accessible by the right audience. Now you need to think about that at the entity level, at the record level, at the document level. So there's some interesting challenges around the governance, especially the propagation of governance changes from data sources into the data hub. There's also the question of what is the security profile for the derived knowledge. When you create metadata, taking into account multiple incoming data sources, what is the security profile of the derived knowledge you've created from that? What is the security profile of that active metadata that you've created? So a few interesting challenges there. I mean, of course, there's also, I mean, I think there was a part of the question was key management, I suppose. Cryptographic considerations are also important. I mean, encryption at rest, encryption in transit. I mean, all those things are part and parcel of the platform requirements. I think in MarkLogic, we've actually pushed that quite far, being able to actually interact with third-party key management, key stores as well, and separating out the different stages of at-rest encryption. So you can choose different keys for at-rest encryption in the database versus for the backups, for example. So different stakeholders, different keys at different elements or different stages of the life cycle.
Yeah. I mean, like I said, there are a lot of advanced features as well within the MarkLogic data platform that have been there for a while and used by security services throughout the world. So yeah, there's definitely more, I think, of a follow-up for that one. But we'll make sure that we get one of our colleagues to reach out to you on that. Another question that came in, and I guess it's kind of, I guess it's like a victim of our success in terms of the messaging that's gone out there. But some of the aspects of the MarkLogic Data Hub documentation suggest that ETL processes are not very important or may not be necessary. Can you explain why this is so? And I'm going to add, why not so? Because I think it's 6 and 2 3s.
Yes, so I'll be controversial and say ETL is actually not an important part indeed. What we really care about is ELT, because the earlier in the process you transform, the earlier you lose data quality, the earlier you lose data precision. I think I mentioned in several of the Q&As, the ability to very quickly iterate on data improvement, iterate on adding metadata, iterate on validating quality between the data consumers and data scientists or the business analysts. If you take a ETL approach, you do the transformation at ingestion time. It's once at the beginning with the assumptions of the person who's loading the data, not with the assumption of the person consuming the data. And different consumers may require different transformation, different assumptions. So the later in the process you do that interpretation, the better. And if you don't have to do any interpretation at all, because you can actually do that through ontology modeling, through overlaying additional data, even better. So yeah, transformation, some of it is absolutely required. I mean, merging data, mapping data, converting certain data format, all sorts of things are absolutely necessary, but do it at the right time to guarantee data quality.
Yeah. I was going to say that, some data use cases aren't actually about transforming the data itself. It's actually about bringing multiple data sources together, just to have that one view in itself. And some of those can be high value to people in itself. And in terms of, like you say, transforming that before you load it, well, you're going to have to do the same thing every time you want to then relook at that data in a slightly different way. So yeah, it's definitely something that to consider.
And one thing as well here is, I've talked several times about active metadata. The more active your metadata, the later you do it, and the higher value you derive from it. I mean, if you're bringing in, let's say, a blob associated to a contract record, a blob might be the actual PDF of the contract. You can reclassify it and reclassifying, adding extracting new facts from that content. So, the ability to do that when the new data points are necessary without having to go back to the original data is really important.
Yeah, and I'd also say, a lot of what people would consider transformative features actually exist within the MarkLogic data platform itself. So that once you load that data and can see that data, you can see what transformations can be done, especially with the Data Hub framework. You can actually get a UI of what that data looks like after it's been through the hub. And so you can see what changes need to be made to that data quite intuitively. So yeah.
I mean, it sounds small, doesn't it? Going from ETL to ELT, but actually, if you tease your last thing, and a lot of that can be semantic in nature, you're not actually doing much T. And the T transformation means change. And the moment you do change, you're introducing noise and potentially a degradation in the quality of the data. So you've got to. So I think that was what Matthew was saying: is do it when it's needed at the right time, and then leave it as late as you can. We've now got MIPS coming out of our ears, as the world, so you can actually do real time transformation when you need it, right? If the business case demands it.
Yeah.
And that can be at the point of use, not at the point of connection or ingestion. And there's a profound difference in the time it takes to get a project up and running and getting value out of the project. That's why it's
Yeah.
and that's and if we get into the real nuts and bolts, and then is the universal index that WorkLogic has, which is a fundamental part of the platform, is really what's allowing that.
And one last question. We've got about 5 minutes before we come to the end, but I wanted to cover this off, which was, why, and we've touched on this, I think, throughout the presentation and throughout the Q&A, but really sort of get to the point of this, which is why add a knowledge graph and semantic dimensions to your fabric?
Indeed, I touched upon that, and explained that the knowledge graph could be considered the nautical chart, the map on top of the metadata hub or the data fabric. But fundamentally, in your fabric, in your data mesh, in a data hub, the unit that you're managing is a data point. Be it a record, be it a document, be it a transaction. You're managing data items, data entities. In the semantic graph, you're managing and you're mapping relationship between them. And if you are considering the entities themselves, yes, you can do search. You can do absolutely fantastic search. You can do facets. You can do pivots. You can do all sorts of things. You can do rollup. You can do BI. Now, if you add the knowledge graph, if you add the semantic graph, you can start walking from a data point to a conceptual idea, back to a data point, up to a concept, up to a logical construct, down to another data point that's related to it. And you can build really complex data experiences, start to explore the relationships, causality, connection between items, between entities, things that you knew and want to measure the importance of, or things that you didn't know about and want to discover. So it's a very different way of exploring data, very network graph oriented, much more natural actually to the human, because that's the way you connect up things in your mind. So actually, from a usability perspective, from a value add in an application, in a decision support system, it is much closer to the way you think, and therefore supporting you a lot better. You don't have to necessarily start reading every document coming back from the search engine. No, you see the map of the knowledge that can be derived from the content.
Yeah, so you're going from that data point to having context, to having meaning, to then deriving insight, and you can see that you can actually see that visually via the knowledge graph, or enhance your search with that extra data. Yeah, no, it's fascinating. Thank you, gentlemen. Thank you for both your time, Matthew, especially, and Jeremy, once again, for your presentation. I think this is a really popular topic this time. We had quite a few people register for this event, so I hope you all found it very informative. There is an attachment that's available to download, which is 3 trends in the enterprise data management. I know that Jeremy worked on that report with the team here, so feel free to download that. If you've got any suggestions of content or topics that you'd like us to cover in the future, please do reach out, csm@marklogic.com, and we'll make sure to bring those up in the future. But gentlemen, once again, thank you for your time, and I hope you have a wonderful evening and rest of your day. Thank you very much.
Thank you for the time.
Thank you.
Appreciate it.
Cheers, guys.
Bye-bye.
Bye.